Welcome to the fundamentals and theory of ground penetrating radar by Geophysical Survey Systems. We will introduce you to the basic concepts of GPR, how it works, and how to interpret the data as it is displayed on your screen. GPR stands for Ground Penetrating Radar. It's an electromagnetic energy signal that penetrates through the subsurface. GPR systems are typically comprised of three elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated here. For example, the Structure Scan Mini contains all three components in one dedicated system. The antenna has a transmitter and a receiver. When the signals are returned to the antenna, we record a two-way travel time and the amplitude of the signal. The amplitude is simply the strength of the signal coming back. Antennas come in various frequencies, depending upon your application. High frequencies are for shallow depth and small targets, ideal for concrete applications. Low frequencies are for typically deeper depth and larger targets, such as utility, geological, and archaeological applications. Survey areas with high conductivity can limit the depth and effectiveness of ground-penetrating radar. An example of this would be clay soils, or uncured or green concrete. Here is an example of objects or targets underground and how the data will be displayed in real time. As you collect the data, note the hyperbolas, or upside-down U-shape, when targets are crossed at 90 degrees. When you back the antenna up, a cursor will appear on your screen. By bisecting the hyperbola with the cursor, this will mark the horizontal location of that target. Radar travels at different speeds through different mediums. A value is assigned to these mediums to represent different velocities of radar. This value is called dielectric. Dielectric is important so the depth of targets or layers can be accurately estimated. Air has a dielectric of 1, which means radar travels fastest through air. Water has a dielectric of 81, which means radar travels slowest in water. Every medium in the world falls somewhere in between. Lastly, remember that GPR is electromagnetic energy. Other sources of electromagnetic energy, such as cell phone towers and two-way radios, may interfere. These will not cause any damage, but may make it more difficult to see deeply into concrete or soil. In addition, unlike X-ray or other technologies, ground-penetrating radar is not harmful and has no site restrictions associated with use. This brings us to the conclusion of the theory and fundamentals of ground-penetrating radar. For more information on data interpretation and specific applications, please visit www.geophysical.com. Thank you.